In this sessions we are going to learn a practical demonstrations of the motherboard. So we are going to check this motherboard practically. We test all the signals. We use schematic diagram. So we open a schematic diagram here. Okay, and what we'll do is we test all the signals. We go to this concept. Here is a concept. You can see here is a concept. This is adapter inputs. First the battery charging section, then the voltage travel from the via this current sensing resistor, then this voltage will travel to this section. This is a 3 volt and 5 volt section, generator 3 volt and 5 volt, and after that this 3 volt is going to the next section. This section is a SIO, PCH and the bias, and these three components are communicate with each other and turn on the laptop motherboard. So we are using a new generation's motherboard. So the concept will be like this here. So this is the concept. This inputs then travel to this 3 volt and 5 volt section. Then here is the SIO, and then here is the CPU. SIO and CPU will communicate with each other and turn on the motherboard. So we'll give the power, okay, and we'll check all the signals step by steps. Okay, so we are using a DC power supply. For that we need a DC power supply, and we need only the multimeter. That's all. Only these two components we require, and we use here a schematic diagram. From that schematic diagram we trace all the signal and we test all the signal. We show you on the screen. Okay, so here we connect this motherboard to the DC power supply. Here is the DC power supply, and here is the DC power supply showing 0.02 ampere current, that is 2 milliampere current. 19 volt is applied here and current is showing 2 milliampere. This motherboard is connected to this DC power supply, and we open a schematic diagram. So here is a schematic diagram, and what we'll do is we'll go to the first section, that is a battery charging section. We'll scroll the diagram. So this is the battery charging sections, and here are these two MOSFET. This first MOSFET, the location is a PQ101, and this MOSFET is a P channel. The next MOSFET is a PQ102, is the N channel, and this one is that controller chips. This one is that controller chips. Okay, and here are these two charging MOSFET. These are the two charging MOSFET here, and that side the MOSFET PQ105, the discharging MOSFET that is connected to the battery. Okay, so here is a current sensing resistor. So what we'll do is we'll check this voltage to this current sensing resistor. The current sensing resistor, the location is a PR102, and the value of this resistor is 0.0 ohms. Okay, so we'll check here. So this one is my resistor, PR102. This one is a PR102. Okay, and these are these two MOSFET PQ101 and PQ102, and this one is this current sensing resistor, and we can check this voltage here on multimeter. This is my voltage coming on this current sensing resistor. So in this way we check this first sections. Now we'll go to the 3 volt and 5 volt section. So we'll scroll this schematic, and this section is a 3 volt and 5 volt sections. This is a buck converter, 3 volt and 5 volt. So this side is a 3 volt and that side is a 5 volt. Okay, and this is a buck converter chips, 3 volt and 5 volt section. The chip location is a PU301, this one, and the chip number is RT8243. Okay, so this is a chip number, RT8243 is a chip number, and location number is a PU301. And this chips have the input pin is pin number 11, that is a VIN pin. That 19 volt coming from the adapter, which is coming here at pin number 11, that will check, and then these chips will generate two linear outputs, that is on pin number 14 and pin number 15 is called LDO03 and LDO05. These are two output signal, output voltages. LDO03 voltage is called the 3VLP, and this 3VLP is going to the SIO. Okay, so we'll check that, and then once this chip get the enable signal, when chips get the enable signal is pin number 2 and 4, pin number 2 and 4, and then this chip will generate this output voltage, that is the buck converter output, 3 volt and 5 volt. But before that, we check this pin number 11 input voltage and pin number 14 and 15 3 volt and 5 volt signals. So we'll go to the board and we'll check all the signals. So this one is this chip PU301, this one square chips, this one PU301, and where you can see the dot, small dot is there on this corner, that is pin number 1, and the counting is going to the anti-clockwise. So 1 2 3 4 5 6 7 8 9 10 and 20. This 20 pin chips, pin number 1 is under this side and it's going anti-clockwise. Okay, so we'll check input first. So here is a pin number 11, 19 voltage is showing on the meter. So you can see here the 19 voltage showing, pin number 11, that is the input voltage. Okay, now we'll see the VRG3 and VRG4. So next we are going to check this pin number 14, that is LDO5. LDO5 and VRG5 both are the same name. Okay, LDO05 and VRG5, LDO03 and VRG3. So now we are going to check at pin number 14, that is LDO5, that is here, pin number 14, and we can see on meter 5 volt is showing. So here you can see the 5 volt is showing. Okay, it's like this. Okay, now we'll check pin number 15. We connect the pin number 15 and then it show a 3.3 volt on meter. So we'll see 3.3 volt on pin number 15. Okay, the 15 on pin number 15, 3.3, that is VRG3 or LDO3. This is a linear voltage and this voltage is going to the SIO. Okay, now we'll go to the SIO page. So now we come on this SIO page. This SIO location is the U17. So this is called the location number of the SIO, and we'll see what is the number of the SIO. So we'll see where is written. Yes, here the chip number is MAC1322. Okay, this is SMSC chips, MAC1322. Okay, now we'll locate these chips on the motherboards. So we'll see on the motherboard U17. You can see here U17 is mentioned on this corner, and this chips is SMSC chips. Okay, and the pin number 1 is on the left hand side. So this is a 128 leg chips. Every 128 legs have their own meanings. Okay, and pin number 1 is the left, and we'll count on the anti-clockwise. So we'll first that 3 volt which is coming from this 3 volt and 5 volt section. So we'll see where that voltage is coming. So we'll see where is the VCC or V standby pin. So here is the VCC. All these pins are the VCC. Pin number 58, pin number 84, pin number 106, pin number 14, 37 and 119. So all are supply pin. So you have to check either any of this pin, or sometimes it's called the V standby also. So that 3 volt which is coming from 3 volt and 5 volt section, which is coming on here. So we can check of this pin, any pin we can check. You can check any pin. So for that we have to keep multimeter on 20 volt and we have to check voltage. So our multimeter is ready, and we connect one probe to the ground and next probe to the SIO pin. So here we connect on pin number 37. This is the pin number 37 and the voltage is showing 3 volt. You can see here 3.4. Supposed to be 3.3, but it's okay. So that 3 volt is coming to the SIO. That means the power is coming to the SIO. Okay. The next signal we have to check that EC reset and lead switch. So we are going to check the lead switch here. The pin number is 64. LIDSW is written here. So on the motherboard we'll check this lead switch. Here is a pin number 64. Pin number 1 is this on the left hand side, and pin number 64, which is I connected a multimeter. So here supposed to be a 3 volt should be there. So we'll see how much voltage is coming on meter. It's showing a 3 volt, right? That means perfect. The 3 volt is coming here on the pin number 64. That means the lead switch signal is coming. That means whatever all the inputs signals are there which are coming properly. So now we'll go to the power on button. There are two power buttons. One is the input and another is the output. We'll check that. First we go on the schematic diagram for that. So you can see here this is a power button mentioned. So power on off button is written here. On off btn underscore kvc, and this 29 here, that is a page number. That means from page number 29 this information is coming, and this is the input signal to the SIO, and on which pin it's going? It's going on pin number 73. So this is a pin number 73 is the input pin to the SIO. Its main signal name is on off button, and there will be a 3 volt. When we press that button, it will go to 0 and come back to 3. So first we'll check this input signal, and after that we'll check this output signal. Again here the on off button is returned, and this signal is going to the PCH, this one, on off button, and this information is going to the page number 6 and 8. And here you can see here is the output signal, on off button, output signal, arrow is output, and this signal is coming from pin number 4. Okay, so we'll first check pin number 73 input signal. So our multimeter is connected to pin number 73 of the SIO, that is power on off button, and it's showing a 3 volt here on a multimeter. And now we are going to jump start. One probe we are connected to the ground, and another probe, this point is connected to the ground, and the next end of this connected to this pin number 73, and that time the voltage goes to 0, and when we release that probe, then it come back to 3. So now we'll see, it will connect. Now it goes 0. You can see here on meter it's showing a 0. As soon as we connect this probe to the 73 pin, another end is connected to the ground, that time it's showing a 0, and when we release the probe, it come back to 3. So this is the input signal. Okay, so in this way you have to check this input signal, power on off button. Now we'll same the replica we'll see on the output. So we are going to connect output on off button, and that output signal is going to the CPU or the PCH, that is a PM power button, and there will be a 3 volt. You can see here 3 volt is showing, and when we press the input power button, at that time this 3 volt goes to 0 and come back to 3. That means the 303 variation will be there. In short, when we press the power button, that is input power button, at that time the 3 volt, that PM power button or the output power button, is goes to 0 and come back to 3. So we'll see practically here. We connect, 3 volt is showing at PM power button pin number 4. We press the power button, it goes to 0, and when we release the power button, come back to 3. You can see here a pulse is coming. You can see here, we'll see once again. Yes, see 0 and then 3. So in this way this pulse should become. Otherwise, if such a changes is not appear on the screen on the multimeter, then in that case our SIO may be bad or EC bias may be bad. So we have to conclude like that. So after that we are going to check the next signal. So in this way we see how things changes in the SIO signal when we press the power button, that is the input power button, and then the reflection of the output, that is a PM power button, is going to the PCH or the CPU, that is a 303 pulse will be generated, and then after that the PCH or the CPU has to respond, and then the PCH or the CPU generate the two signal, and the signal is named SLPS3 and SLPS4, slip 3 and slip 4. These are the two signals generated by the CPU or the PCH. Up to third generation PCH will be there, and after third generation CPU will be there. Okay, we will check SLP3 SLP4 signal on the SIO, and before power on button press it will show a 0 volt, and once we press this power button, then it goes to 3 volts. So now we are pressing a power button, and then it will show a 3 volt, and then it's a 3 volt. You can see here. Okay, same like SLP3 also, same thing. So now this is SLP3 signal and it's showing a 0 volt. Now once we press this power button, we'll press the power button, we'll jump start by using a multimeter probe. Okay, and then it will show a 3 volt. Yes, it is showing a 3 volt after power button press. So now our board is turned on. Okay, like this. So now friend, we check all the sequence like this from inputs. Then there are 2 MOSFET. Then it's going to the current sensing resistor. Then this voltage is going to the 3 volt and 5 volt section. This 3 volt and 5 volt section generate VRG3, and that voltage is going to the SIO. Then we press the power button. Then PCH communicate and generate SLP3, SLP4 signal, and in this way board is turned on.